Alrighty, we are now on example 9. I chose this problem because this would be a nice example of an AP problem that the parts really are not related to each other, so you really will treat the parts independently and hopefully not get too flustered about it. So here we go. Suppose h is a one-to-one function, which is differentiable for all real numbers x. The table below gives some values of h of x and h prime of x, and you'll notice that those values are given. Right, we have 3 different questions going on here. I would encourage you to try the question, see if you can get anywhere with it, and then come back and each time just check your parts. But if you're feeling pretty stuck, then feel free to just hang on with me throughout the whole video. All right, part A asks me to find an equation of the tangent line to the function h of x at x equals 4. So notice this time it has nothing to do with an inverse. It just asks us the function h of x at x equals 4. So I know that we need to find the slope, which we're dealing with h. It's going to be h prime at 4. And we know it's at x equals 4, so it's going to be the point for something. So the first thing to find h prime of 4, we can simply just find h prime of 4 on the chart at x equals 4. H prime is equal to 5. And then the point 4, that's basically just asking us for h of 4. So we look at the x value of 4, the h value is equal to 7. So we have just found out the point is 4, 7. And now all we need to do is write the equation of the tangent line, which will be y minus the y value is equal to the slope, x minus the x value. And that was really all they were asking us to do in that one. Right, part B says to write an equation of the normal line to the function h of x at x equals 4. If you recall, a normal line is a perpendicular line. So once again, if we're going to find a line, we need the slope and we need a point. Well, the point's going to stay 4, 7. And here, if I have a perpendicular line, if my slope was 5 in the original problem, the slope of my perpendicular line will be negative 1/5 because it is the negative reciprocal. So we are all set, once again, to write the equation. I'm going to have y minus the y value equals my new slope times x minus the x value. And then we get to be done. Right, part C, write an equation of the tangent line to the function h inverse of x at x equals 4. So this time it is asking us for an inverse. So a few things. The first thing that we need to do is we're going to find the slope, which in this case will be the derivative of the inverse at 4. And then please remember that now that we're dealing with an inverse, it is going to be 4 something, but on the original function, it is going to be something comma 4. So just keep that in mind. So we're going to go ahead and find the slope first. So to find the derivative of the inverse at 4, it is going to equal 1 over h prime, h inverse 4. Yes, my husband is still working on our house outside, and I get to do videos instead of being out there. This is going to equal 1 over h prime. When I'm finding the derivative, the inverse at 4, again, I'm going to be looking for up here in the original function, the y value is equal to 4 when x is equal to 2. So 2 4s on the original function, which means on the inverse, it's going to be 4, 2. So the inverse at 4 is 2. And now I'm going to be looking for h prime of 2. When x equals 2, the derivative is equal to 1/6. So it's going to be 1 over 1/6. 1 divided by 1/6 is 6. Please remember that gives us m. And then I'm going to squeeze down my answer here. I'm going to have y minus the y value is equal to my slope, which is 6, x minus the x value. And I have now found 3 different equations of tangent lines that really had nothing to do with each other. But hopefully you were able to tackle it and feel pretty good about it. All right, thanks.